Our final lesson in Chapter 2, Lines and Angles, Formal Proofs. Lines and Angles, Formal Proofs. Please note the date and location that you are watching this video. Don't forget to get a parent signature. We're going to recap parallel lines, and we learned in class, it says in the diagram below, stretch out the parallel lines. Lay down your stir stick and solve for the unknowns. Find all possible angle measures in the diagram. So step one, when you're dealing with parallel lines, first thing you want to do is always stretch them out. Always stretch them out. So we're going to take these lines here, we're going to stretch them out. When you stretch out parallel lines, it helps your mind see the possible kinds of angles here. Okay. Next, we're going to lay down our stir stick. I'd like you to get your physical stir stick. You were provided one. And there's actually two transversals here. We're going to start with this one here on the left. I'd like you to lay down your stir stick right there. Now I'd like you to physically sweep these angles. If we're working with these lines, this is called the interior. I'll just write the interior. So in this case, one is in, excuse me, that's the out. One is out. One is in, same side. These are called corresponding angles. These are called corresponding angles. These guys. Corresponding angles are going to be congruent. So we can solve this. 2y equals 80. Just divide by 2 here. And of course we get y equals 40. So let's find all angles that we can. If this is 80, then this is 80. And then there's one more corresponding angle, that's also 80. And then here, that's a linear pair. That's 180. That means this angle right here is going to be 100. Then this is corresponding this way. This is 100 as well, and that means that is 100. So that's one stir stick. Let's try the other one. Move your stir stick over to this side. And let's see what we can find here. Whoops, we forgot a lot over here. I'm sorry, I forgot the other side. So if this is 100, then this would be 80 on this side. This is 80. This is 100. This is 100. And when this came out this way, this was 80 going that way. Okay, let's take a look at this stir stick here. This is our interior. Let's sweep our given angles. These guys, these are what's called consecutive interior angles. These are not congruent, but they do add up to 180. So 4x plus 120 equals 180. X equals 15. So here, 4 times 15 would be 60. Now let's walk this through what else we can find. If this is 60, this is 60 over here. We can do armpits of the Z. That means this side is also 60. That's 60. Armpits of the Z again. Alternate interior angles, this is 60. If this is 120, then over here is 120. That means this is 120, this way is 120. This way is 60 as well. Over here, that's 120, and that's 120. So we have our variables, and we have every possible angle in the diagram using parallel lines. Now, in formal proofs, all we're doing is, again, taking an explanation and we're specifically addressing these questions in a formal proof. An informal proof is a paragraph or a narrative which describes both the how and the why of a geometry problem. It's a paragraph or a narrative. So an informal proof is when you're just writing sentences. That's called an informal proof. A formal proof is a systematic diagram. So formal proofs involve some sort of diagram setup that also explains the how and the why of a geometry problem. There are two types of formal or systematic diagram proofs. One is called the two-column method, and the other is called the web. In the two-column, the how goes on the left, the why goes on the right. It reads like this: I know that, whatever, because of whatever. How on the left, why on the right. That's called a two-column. Now, webs are a bit unique. Webs, the hows go in boxes. So they're like puzzle pieces. The whys go between the boxes. They're like the permission to take each step. Now, we're going to do just one of each. This is the first time you're really doing this. You are not expected to fully understand this first time. This is just an exposure. So bear with me. It is important that you are extremely familiar with this section in your reference book. Again, find your geometry reference, find the first blue section, How To. You should flip through these sections here: algebraic properties, how to show angles congruent, and other angle theorems. Okay, step one. We're going to do one web proof together. And we're going to start by following GIFT. Given, line S and T are parallel. So we trace S, we trace T, and we note that they're parallel. And L is also parallel to M, so trace. So it's parallel going both ways. And you're given that the measure of angle 13 is 70. That's given. Let's look at our target. Our target is we want to try to figure out, given this circumstance, how do we know angle 3 is 110? So I'm going to come over here. I'm going to put 110, and I put a question mark by it because that's our target. That's our target. Okay, so we're going to mark what's implied and brainstorm here. How do we get from one to the other? We're going to take our stir stick, and since 13's over here, we're going to lay down our stir stick. And let's just work that and see what we can find with implied and freebies. So implied and freebies. On that stir stick, we know 13 and 2 are congruent. So 13 is congruent. I'm doing a little brainstorm to angle 2. And the reason why, across the stir stick, those are called alternate exterior angles. And we can do that because lines cross the stir stick, L and M are parallel. So that was because L is parallel to M. Now, if we move our stir stick, we can go this way because of the parallel lines. Now we can do S and T are parallel. Because S and T are parallel, I can say that angles 2 plus 3 have to add up to 180. Why? Because they are consecutive interior angles. And that is because S is parallel to T. Now, because they're consecutive interior angles, we have 2 at 70, and 180 minus 70, boom, gives us 110. So there's our little brainstorm we can use to do what's called a web. So let's talk it through again. We know 13 and 2 are congruent because of alternate x. And then we know 2 and 3 are consecutive interior, so they're supplementary. So they add up to 180. So we're starting with 3 basic given pieces of information. That's our first 3 boxes. 1, 2, 3. We are given that L is parallel to M, S is parallel to T, and the measure of angle 3 is 70 degrees. Let's see what we can do here with this. We're just going to start with the parallel lines. Let's just start with that. How do we know both of this? It is given. Okay, now because L is parallel to M, we were able to get these 2 angles congruent, 13 and 2. So I can do this. I can say angle 13 is congruent to angle 2, and the reason why is if parallel, alternate exterior angles are congruent. So our how is in the box and our why is there. Now over here we know that the measure of angle 13 equals 70, and why do we know that? It's given. And if we put these 2 pieces of information together, 13 is 70 and 13 is 2, we can say that the measure of angle 2 equals 70 as well, and that would be substitution. Now, because of the stir stick S and T being parallel, we can say this, that angle 2 plus angle 3 equals 180. Why? Because if parallel, consecutive interior angles are supplementary. That's the why. And here, angle 2 is 70. So we're going to take these two pieces of information and put it together. So 70 degrees plus angle 3 equals 180. Why can we do that? That's called substitution. You minus 70 both sides, and we get the measure of angle 3 equals 110. And why can we do that? That is the subtraction property. So that's called a web. You put the how in the boxes and the why between the boxes. So every step you take has to have a why to describe it. I'm going to leave this up so you can finish copying this down. Again, this is your very first example. If you're feeling confused right now, this is perfectly natural, perfectly normal. Just take the time to write it down. That's called a web proof. Your two-column proof is similar to what you've been noticing in class. So let's walk through given right here. Let's bring this real close. Given ray CR bisects FCA. ACP is a right angle. That's right, so that's 90. Okay, that's given. Now part of the given we look at right here. We're going to prove that measure of angle PCZ, that's what should be there. We want to prove that that is 45 degrees. So 45, put a question mark. That's what you're trying to prove. PCZ is 45 degrees, and you're trying to prove that. Okay, let's brainstorm. Implied and freebies. Well, it's implied that if you have a bisector, these two guys are equal. And if it's 90 over here, you also have 90 over here. So we just slice 90 in half, and we get 45 and 45. Freebies, things that are true, even if they're not in the given. Can you trace RZ, please? Now trace FP. Lo and behold, we have bow tie angles. Those are called bow tie, or vertical angles. They're congruent. So if this is 45, aha, that's 45. Now we've already talked ourselves through that. So let's recap what we did. We started with the right angle, and then we bisected the right angle, and we got 45 degrees. When we got 45 degrees, then we just talked about vertical angles, which means they're congruent. So that's like a little baby brainstorm, just to keep track of your reasoning. Now we're going to organize this logic into what's called a two-column proof. And you do the how on the left, the why on the right. It reads like this: I know that because, and it's two column, because we make this in a two column. So let's start with our given information. We know that CR bisects angle FCA. We know that because it's given. We also know that angle ACP is a right angle. R with the circle means right angle. We also know that because it's given. Now we have to go to implied stuff. If this on the right is 90, then the left is 90 as well. So we can say angle FCA is 90 degrees. Why? Because if 90 one side, 90 other side. That gives the reason why you can do that. Step 4, I know that the measure of angle FCR is 45 degrees. Why? Because bisect 90 degrees is 45 degrees. We can cut that in half. Now we have to connect what we're trying to connect. We're trying to somehow connect PCZ. So step 5, I can say angle FCR is congruent to PZZ. And the reason for this, that was step 4, the reason for this is because they are vertical angles, and all vertical angles are congruent. Now circle with me. Here's FCR, 45. Here's FCR again, so we can replace FCR with 45, so we can finally say the measure of angle PCZ is 45 degrees, and the reason is because substitution. So that's called a formal two-column proof. A formal two-column proof. So the two formal proofs on the left would be the web, and on the right would be a two-column proof. Next class, it is very important that you bring both a straight edge and a compass with you. A straight edge and a compass.